We are on lesson 1-9 for AP Calculus using iPad today. Today's date is Friday, September 4th, 9/4/2020. Man, writing with an Apple Pencil is way nicer than using my $80 little tablet. Our lesson today is just review intermediate value theorem, extreme value theorem, and mean value theorem. If I actually wrote those all out, I would not have enough room in that title space. Our objective today, go for it, Andrea.
Know when to use and then use IVT, EVT, and MVT in a variety of problems.
That is a weird typo. Know when to use. And then I'm not sure what I was trying to say there. I think we're just going to cross all of that stuff out. Know when to use those things in a variety of problems. Oh, know when to use and then use. I see what I was saying. I could have said that better. So what conditions can I use them? And then how do I actually use them? Got it. Okay. So IVT, intermediate value theorem. What does it need? It needs to be, look back through your notes and I'm gonna wait for you guys. IVT, I think it was like 1-5-ish. Fiona knows. Yeah, go for it, Fiona.
It needs to be continuous.
Continuous, everyone write it down. Continuous. Perfect. And then what does IVT prove? Just one word, as simple as possible. Is it slopes? What is it? It's not slopes, it's something else. Just one word. Again, just look back through your notes. This is our review day. Andrea.
Heights.
Heights, it proves heights. And if you want to do a picture, remember when we made our rectangle, it proves all heights, whatever is in that rectangle. All right. EVT, what do you need? Extreme value theorem. I'm going to give it to Teflon. Look back through your notes. EVT, you need two things.
Closed and continuous.
It needs to be closed, and secondly, it needs to be continuous. And just as a reminder, when I'm closed, that means I either see symbols with square brackets like that, or you can have symbols like this if an X is in between certain things. And then what does extreme value theorem prove? There's two words that you need to know for this one. Fiona, again, go.
Oh, I don't know what the words are, but I was going to say I thought it was like F of B minus F of A or something.
Oh, that's mean value theorem that you're thinking of.
Oh.
Yeah, that's okay. And that's actually the formal definition too, which is even better. But extreme value theorem, it proves extremes, but what are extremes? Extremely at the top, extremely at the bottom. What are those things called? Andrea?
Is it minimums and maximums?
There it is. It proves minimum and it proves maximum. And it only proves their existence. It doesn't say where they are, it just says, hey, there is a minimum and there is a maximum. And then finally, mean value theorem, what do you need? Needs one word here. Go back to yesterday's notes. This is from 1-8. It needs one thing. There's a table there at the bottom of the front page. Starts with a D. Teflon?
Differentiable.
There it is. It needs to be differentiable on the entire function, or at least the interval that you're talking about. Oh no, I hit the button because my pinky touched it. Where are my notes? Oh gosh. There, good notes. Needs to be differentiable. And then there's one word that this proves. Mean value theorem proves what? Andrea?
The slope.
Slopes, exactly, or the slope. I'll just say slopes. Some textbooks state mean value theorem needs to be differentiable and continuous, but you don't really need that, because if you're differentiable, then you are by default continuous, because part of the definition of differentiable says, hey, you have to be continuous, you can't have sharp corners, and you can't have any vertical tangents. So it's part of the definition of differentiable. That's why I'm not writing continuous under here, because it's assumed that you're continuous since you are differentiable. And I do want to put this down here too. If you are, oops, that's the wrong way. If you are differentiable, that implies this, this symbol right here is implies. That implies that you are already continuous. And we'll be writing this later in our proofs, that if you're differentiable, that it implies continuous. But like, for example, if it only tells you that the function is differentiable, can you use intermediate value theorem? I'll repeat the question one more time because it is important. If I am only differentiable, am I allowed to use intermediate value theorem? Fiona's nodding your head, yes. Why?
Because if it's differentiable, then it's continuous, and for intermediate value theorem, you just need to be continuous.
There it is, well explained, yeah. But whenever you're writing out your proofs, you need to say this thing. And you can say, like the most abbreviated way is you say diff implies, oh, that's a horrible arrow, diff implies continuous. If you just put this somewhere at the top before you start using IVT, then you're done. Although everything that we have for our tests, our pre-tests, our self-checks, everything test-worthy is multiple choice for this unit. So you don't have to write this down until we get to like unit 6. Unit 6 is when we do free response. Cool. That's all I have for you guys today. So let me go ahead and stop the recording here.